Request President Sir to please accompany Vijaya ma'am, who is our guest speaker today. I would request Mr. President Sir to welcome Ms. Vijaya ma'am with a bouquet.
Is basically trying to mimic human intelligence. We are currently at the stage of what we call ANI, artificial narrow intelligence. That means we are able to simulate human intelligence in a narrowly defined intelligence, which is going to be the next phase of development for artificial intelligence. We are not there yet. And after that, the projected development in AI is going to be ASI, artificial superintelligence. And whether it's anybody's guess, we don't know whether it is going to be a Terminator kind of a scenario, or it's going to be like a godlike scenario. We don't know yet, but we are fortunately still in ANI phase, and it's doing wonders for us already. Can anybody tell me the real-life examples of artificial intelligence that you have seen before, or you may have experienced before?
Complex heart operations.
Complex heart operations, how is it artificial intelligence? Is the surgeon involved or not?
No, the surgeon is not involved, and there's an infection and the heart has been exposed in a very natural.
Robotics. The use of robotics along with the, okay. Yeah, that's one example, but there are much bigger mass consumer applications that you have already used. You just need to get that out of your thought process. Okay, so I'll go into the applications. When you see the applications, you will know that they are actually AI apps. So today's agenda, I'm going to go quickly about my background, which Praveen has already covered. So what I'm going to do is, rather than repeat what Praveen said, I'm going to just give you a few anecdotes that Praveen has specifically asked me that to tell you a few stories so that you can see kind of your future, like, you know, you can understand what we learned after leaving OU College of Engineering. And then I'm going to give you AI applications as we just discussed, so that you will see, this is AI, okay. And then I'm going to give you a technical foundation. I'm going to keep it very high level intentionally, a couple of reasons, because I am actually not from the source background. I do have good technical understanding, but I'm not from the machine learning specialization. But that is one reason, but the bigger reason is time. I want to make sure that give the technical foundation just enough so that you understand the kind of the careers opportunities you have available in this field. And also, if you are interested in starting your own business, what kind of steps, phases that you need to go through, and what kind of resources you will be needing, both human, hardware, software, whatnot. And then finally, I'm going to give you a very quick overview of the product development and deployment life cycle of the artificial intelligence machine learning based solutions, so that you will know from that where you fit from your career perspective. That's pretty much it. So let me just quickly go through the background. Well, anyway, we have talked about all this. So there are few things that I've learned, few things at OU as well as after OU. One of the big things I learned while at OU was a comment made by one of our lecturers, a civil engineering lecturer in second year, first term. I remember it so well. Yes, when I say that, you might remember. You know, one day he walked in and he asked us one question. He asked us, what is the difference between a mathematician and an engineer? Can anybody tell me? This I learned at this in electrical engineering building. No, in the main building, because we don't have a proper building. Yeah. Anybody just take a wild guess or whatever you think. The difference between a mathematician and an engineer.
Mathematics is a tool for math, tools for engineering.
Good. He gave us it's true. It's true. Mathematics is one of the foundational tools of engineering. he gave us this example. He told us that if you give an orange to a mathematician, he will look at it, he will tell you the circumference of the orange, the area of the orange, the radius, the diameter, etc. If you give the same orange to an engineer, he will peel it and he will eat it. So the difference between an engineer and a mathematician is engineering is an application field. So my dear friends, focus on applications. Okay? Whenever you are learning theory, ask yourself what is the application of this theory. That's why I asked you the question, have you experienced an artificial engineering application? Whatever you are doing, ask yourself, how does it apply in real life? What am I going to do with this? And whenever you see an application, what is the theoretical foundation of it? Without application, there is no engineering. Theory is very important. Mathematicians and physicists are very important. Without mathematicians and without physicists, engineers are not there. But without engineering, there's no bubble, but there is nothing here. So engineering is a field of applications. Focus on it. Eat your orange before you describe it. And the other thing that I learned was, of course, BHL R&D. When I joined BHL Corporate R&D, I was blown away. We went through a lot of training. I was blown away by the BHL infrastructure. I didn't know that BHL was that big. They took us everywhere, to Trichy plant, to Tamil Nadu, to Bangalore, to Delhi. So many BHL plants. I did not know that BHL was that good and that great. Another thing that I learned, I wish I had known BHL before I joined BHL. Another thing, take time, go to these good public sectors as well as private sectors. If needed, take alumni help. Like you want to visit GE, see if Kanan can arrange something for you. If you see it, it's different. When you actually see these big corporations, it's different. It hits through like anything. There is world outside the classroom. Visit as much as possible. Go after your HOD. Go after your faculty. Pester them till they take you to the public sectors, the big corporates, and go after your alumni. We are there. Just ask us. We'll take you. We'll take you to the corporate houses. Go to Google. Go to Facebook. Go to Microsoft. See their campuses. Talk to them. Don't be scared. They are not smarter than you. They're also the graduates of this. Just ask them. The gentleman here in black shirt, he's not scared to ask questions. Ask questions. There's no stupid question. Only stupid question is the question that was never asked. Okay? So go ahead. Go see the world. Okay, the other thing that I learned after I moved to the USA was I did my master's from Rensselaer. Rensselaer is one of the top 5 engineering colleges, especially for electrical engineering in the US. You know why? If you were ever bothered by Resnick and Halliday physics books, you will know Rensselaer because they are professors from RPI. If you ever bothered by Alan Greenwood's transmission lines books, you will know because Alan Greenwood is the professor from RPI. It's currently known as Rensselaer. You know why Rensselaer is also famous for? Because it's stone's throw from GE Corporate R&D. When I joined RPI, I got internship at GE Corporate R&D in Muscatine, New York, and GE has sponsored my master's thesis. That is the kind of the handshake between industry and engineering college. We have BHL Corporate R&D here. I don't know how many theses are sponsored by BHL Corporate R&D. Come on guys, go ask BHL. It's public sector. They should sponsor you. Have handshake with the industry while you are here. It's your right. Go ask. That's another thing that I learned. GE has sponsored my master's thesis. They paid for it. They gave me the data. They gave me access to their corporate world. I've learned a lot. Ask for it. Just go ask. And the other thing that I've learned with Nuance Communications. When I joined Nuance Communications, by the way, Nuance is a commercial spin-off of SRI International. SRI stands for Stanford Research Institute. It has nothing to do with Stanford University, it has the same name. But it is physically very close to Stanford University. Stanford is in Palo Alto, California. SRI International is in Mountain View, California, which is right next town. The beauty of SRI is it's primarily funded by DARPA projects. DARPA stands for Defense Advanced Research Project Agency. It's similar to DRDO of India. Okay? Whereas SRI does commercial spin-off of its research. I have never heard of DRDO doing it. Come and ask Modi or whoever you need to ask. DRDO. Come on guys, come out with the commercial spin-offs. You are doing so much research. There are a lot of research goes on in DRDO. My uncle worked for DRDO. He's a very smart guy, but I have never seen him talking about the commercial applications of their research. I know defense is a core secret. So is US defense. But they do commercially spin off some of their technology, and that is the fruits of the technology that we are now using. So ask why, Indian research institutes have to go out and do commercial spin-offs. There's another thing that I learned in the US. Another thing that I learned was nuance communications. When I joined, I was employee number 30. It was a startup. I was the first woman engineer. I was the first non-white. I was the first non-American to be employed by nuance communications. I've seen nuance from the OU College of Engineering has a brand recognition in the US. RPI, most of the toppers from chemical engineering, every year go to RPI. They know OU very well. Be proud of yourself. OU College of Engineering, they know in the US, it has brand recognition. We just have to market ourselves better in this country. By the way, nuance. So, it is one of the most successful startups in the US history in artificial intelligence. So when I joined in 1996, the first commercial deployment of artificial intelligence happened, which was the Charles Schwab Stop Code system, natural language speech recognition based system. And then we went through the whole series of round A, round B, round C, financing, etc., and went through the upheavals of creating platforms, creating new technologies, creating tools, coming up with new partnerships, marketing, sales, everything, because we were the early employees. I've seen the product development life cycle. I've seen the startup life cycle. Fortunately, I've seen the successful startup life cycles. There are many ways to fail. There are very few ways to succeed. And fortunately, I've seen the successful, and that was just luck. Because nuance also had equal chance of failing. Another thing that I learned is how startups succeed. If you have any questions, you can ask me after that also. Startups. So, Axiom Corporation. Fortunately, I had an opportunity to work for Axiom Corporation after I did my MBA. Axiom Corporation is the largest data analytic firm in the world. So, if you ever wondered that you book a tour and you call SBI as on credit card and they ask you, can we offer you some credit loan offer with some discount on interest rate for your travel trip, and you're like, what's the heck, how do you know? How do you know that I'm traveling? It's like these marketers know in and out of us. That's thanks to companies like Axiom Corporation. The kind of the amount of the data they collect on daily basis about everyone in the US, if anybody ever forgets their address or phone number, their name, they can go to Axiom and ask. They will tell you more about you than you ever know. So that's Axiom Corporation. So with this combination, I've learned a lot from Nuance and Axiom Corporation, which fortunately happen to be the hot fields today, artificial intelligence and data analytics. But I was mostly into the front end, human-machine interface, as well as I was in marketing and general management. But I do have enough technical knowledge to cover today. iPhone Siri, have you ever used it? Have you heard of Dragon naturally speaking? Indian Supreme Court, Indian High Courts know about it because it's used in transcription. Indian medical transcription companies also know about it because they use this system to transcribe doctors' recorded versions, and they use this system in courts in India to transcribe the court proceedings. Google Voice. Do you know what it is? Google Translate. Have you tried it? Have you tried speech to text to text to speech? Google Translate. Try that if you haven't. You not only type, you can actually talk to it. I think it has Hindi, but I don't know. I don't think it has any regional languages. Amazon Echo, you may have not tried because it is yet to be launched in India. Microsoft Cortana, if you have the latest version of Microsoft OS 10, you will have Cortana on your computer. Sideball and second year other applications. Google's and Facebook image recognition you may have heard of. Like Facebook, you know, the annoying thing, it asks you, can I tag you as this other guy? That's Facebook image recognition. Sometimes it gets it right, sometimes it doesn't, but it's Facebook image recognition. And Zillow's estimate. I don't know, I'm not sure whether is there an equivalent application in India for Zillow? The real estate? Not it, right? No, there is one for you, you can start.
Housing.
Housing. Is that predictive? Can it predict the house price? I mean, guesstimate.
No, I don't think that
Okay.
they have the data.
They have, data is the big problem in India, but we can collect here. Okay. So this is another thing, Zillow's estimate. What it does is, if you give the address of any house in the US, it gives you the guesstimate. It guesses, like within a certain range, what the price is going to be of that house. And you may have experienced Amazon's product recommendations, like you buy something and it also says, oh, this is another recommended product for you. What do they all have in common? I'm sorry?
Interaction with the customer.
Yeah, they have interaction with customers, that's true. What are they based on? The foundational technology?
Past data.
Yes, they have past data. Yes. They're based on past data. They're artificial intelligence and machine learning applications. They're all of them. Yes, they're based on past data. Let me just quickly try to demo Siri.
The high temperature is 84 degrees.
Who is the Prime Minister of India?
Checking.
Back.
Where is the speaker?
Yes.
Yeah. Still checking. I mean, you better know Indian spellings. It will come on. It will come on. I think the Wi-Fi. Anyway, yeah. This is Google Voice. Who is the Prime Minister of India?
Narendra Modi is the Prime Minister of India.
Who is the Prime Minister of UK?
Theresa May is the Prime Minister of the United Kingdom.
So, okay, so speech recognition. Siri, iPhone Siri, the technology behind iPhone Siri is provided by Nuance Communications, the company that I worked for. Nuance also owns Dragon Naturally Speaking, which is what we call speaker-dependent model. Google Voice was developed by Google within Google, but it was headed by my Nuance's manager, Mike Cohen. So Mike and I worked together on natural language dialogue analysis for the human-machine interface, which resulted in a US patent for us. After that, he left Nuance, joined Google, he headed the speech recognition department there. So actually, there's a lot of similarities you will see between Google and Nuance. But now Google uses neural networks. So Zillow's estimate is, okay, Zillow's estimate, the way I've told you about it, it's the house price predictor. Okay. I don't know how many of you actually tried Siri settings. We actually get a lot of complaints that Siri is not recognizing properly. Or Siri is not pronouncing certain names properly. You know, sometimes it says Modi, Modai and all that. What you need to do is go into settings and you change the language. It depends where you bought iPhone. If you buy iPhone in US, it defaults to English United States. If you buy it in India, it defaults to English India. If it buys, say UK, etc. And Siri's voice also by default is set to something. Sorry? Yes, models will change. That's the technical answer. Yes, that's right. Models change. What happens is it's not just very simple setting like change the color from green to blue. What it does is it loads the appropriate model, the machine model that is appropriate to what you are choosing. For example, if I switch from English United States to English India, it loads a model called EN. Basically means it's trained for Indian accents. So if you're more of Indian accent, it better switch to English India, then it works better for you. But although from research we have seen that Indian accents, English US also works fine because Indian English model was based on English US model. And Siri voice is what she speaks back to you. You can switch from male to female, you can set it to others also. In India, we have released a lot of models. But Siri, I think, is only giving 1 or 2 models because they have not licensed so many from Nuance. So they have licensed very few. So you create models based on some data, and then it's very important that you use the right model for the end user population. So in many artificial intelligence applications, you should give some kind of ability to your developers or the front-end designers to be able to switch these models. Okay, what's the difference between programming versus machine learning? Computer science, who is here?
So in programming, we are telling the machine what to do, when to do. In machine learning, we are teaching to think what to do, when to do. It means we are not predicting the we are giving the knowledge to predict the situation and react accordingly. But in programming, we are telling what to react, when to react. In machine by doing machine learning, the machine will predict and it will react accordingly.
Yes, that's pretty much good. Program is instructional based. You are literally giving one instruction at a time, and it's like a dumb machine, it does it. Whereas machine learning is experience based. We're trying to simulate the experience by giving it a lot of data and then asking it to learn from the data, so that when you give it a new scenario, based on the experience from the data it learned, it will predict or it will recognize what you are trying to do. I'm going to give you a very simple example. I'm going to simplify the machine learning here. It's not that simple, but conceptually it's similar. For example, you're a real estate agent, and you're a builder. You're building an apartment complex. You're building an apartment complex, and all apartments have very standard structure. Naturally, the whole complex is in one particular area. Then you can go with programming-based type of scenario for setting the price. You can just have a formula there that says if it's 1,000 square feet for each, for each square feet I will charge 2,000 rupees, and for each bedroom I'll charge an extra 1 lakh rupees, and I will keep a base minimum cost of just the structure as 5 lakhs. So you can just give it and write a simple application that just gives you the calculation. This apartment has 1,000 square feet, 2 bedrooms. Okay, that will be like some 27 lakhs. It will calculate. It's a very simple mathematical formula, as you can see there. Suppose you're a real estate agent, and a lot of houses are coming for sale in Hyderabad. And these guys, they go into a Jubilee Hills and say area, and they see like a 3,000 square feet, 3 bedroom, and they say, this will be 4 crores, nothing less. You take them to Indira Park, similar house, and they're like, okay, fine, 1 crore. You take them to Vijaya, like, okay, 1.5 crores, whatever, right? And then you take them inside and like, oh, no, I changed my mind now, it will be around 2 crores. So these real estate agents seem to know something, and that's what we depend on, basically. How do you set your price, right? You basically depend on the knowledge of the real estate agents. So how do they know so much? It's because they've been in the industry for years and years, and they have gathered the data in their mind. They literally know the variables to look for. They know that area matters, they know that square feet matters, they know bedrooms matters, they know year of construction matters, they know whether it is close to metro or not. So many other features. Based on that, they give you the guesstimate. And then of course it depends on your negotiation power. But at least you should know the range. When you are either buying or selling, you cannot just go blindly buy. You should have a range. And for that range, you are usually dependent on your real estate agents. So the idea here is, suppose we want to mimic what real estate agents do in computers. How do we do it? Okay? I'm going to make you do it now. Very simple mathematics. Don't be scared, just answer, okay? 1,000 square feet house or an apartment, 1 bedroom, listen to it carefully, costs 11 lakhs. Don't ask me where because I know it's too cheap. 2,000 square feet, 2 bedrooms cost 22 lakhs. How much 3,000 square feet, 3 bedroom will cost? 33 lakhs, right? I never told you per square feet. I never told you per bedroom. How did you figure out? Huh? What did you do? In your mind you did something. You had a pattern, you figured out the variables, you did a very good calculation. You calculated that for each 1,000 square feet it's 10 lakhs, for each bedroom it's 1 lakh. You did that calculation. That is, mathematically speaking, you figured out the coefficients of that formula from the data, from the real data. So what I told you was, I did not tell you the coefficients. I told you the price. I told you the variables. You figured out the coefficients. That is machine learning. It's as simple as it is. Okay. Of course, in real life, you don't have just 2 variables and it's not as simple as it is. You have a lot of variables, lot of sales data, lot of variability within the sales data. But nevertheless, using statistical regression models, first degree or second degree, third, whatever, polynomial equations, you can pretty much do this in computers. You can just do a linear regression algorithm and let the computer figure out these coefficients. In statistics, we put the hat to say that it's an estimate. That's all we do in machine learning. What we do is, we give lot of data. The data, by data I mean we actually give it the sale price, the real sale price that happened. That's what the real estate agents know in their mind. They know that in Jubilee Hills, road number 36, last month this house sold for 4 crores. In Vidyanagar, yesterday this house sold for 1 crore. They know that. That's how they predict. Why can't we just take that and let the machine do it? That's what we do. That's machine learning. So now the question is, how good are we? How do we know that model that we built is right? The estimates that we just did are right. There's something wrong with something. It's not really wrong, but something not good enough with what we just did. What is it? I gave you 2 data points and asked you, and you gave me the 3rd data point. In real life, that's not that easy. What else should happen in real life? What do you need in real life? Yeah, you definitely need more data. And what else you need?
Factors pertain.
Absolutely. You need more variables. Because real estate agents just don't depend on square feet and bedrooms. They depend on a lot. So, what happens is, this is how models can go wrong. This is where, the Facebook does those annoying mistakes. It tags you as somebody else. It doesn't have enough data about your picture. It has enough data to know that you are a human and you are not something else. Like you are not a car, but it doesn't have enough pictures of you. So that means you not only should have more data, you should have the right data. So the more and more data you give it to it, the more and more variables that are realistic. Don't try to overfit to the outliers. In statistics what an outlier is, right? In Jubilee Hills, every house sells for 5 crores and suddenly one house sells for 1 crore or one house sells for 30 crores. That's an outlier. Don't fit your model for that. But you sometimes don't know that it's an outlier. So models at best give you the estimates. They don't give you the right answer. They're giving you the best estimate. So models always have error. Always. No matter how good a model is, it will always have an error. So the best thing to do before you release the model to your consumers is to estimate the error. How do you do? How do you know? How can you estimate what is the predicted error of this model? Do you see, like, in politics, when the general elections happen, they say that Modi has, BJP is going to win 200 plus seats, and the sampling estimation error is plus or minus 3 percentage points. They even know that. How do they know that? How do you evaluate a model?
Response.
Go ahead.
Response.
Response of what?
Survey.
Yes, in survey only you have responses, but they're also estimating the error itself. Error can be 20% and they can be widely off. Even the Zillow's estimate, it can be widely off. How do you estimate? You need something to estimate your error.
Actual value.
Yes, you are using action value for training data. You need something. You need test data. You need to test your model. So where do you get the test data from? You know where to get the training data from. You collect it from for example, in the real estate examples, you go to your sub-registrar office. If you believe them, you take the data, you collect it, you create the model. Where do you get the test data from? Yes, it is same. Yes, so what you do is, when you collect the training data, you keep 80% of it is as training data, 20% of it is test data, so that you are preserving the randomness of the sample. What we do is, for example, you have collected, say, in Vijayanagar area, 100 houses, okay? And you have collected their variables, everything. 80 houses you use for training the model, 20 houses you set aside. You make sure that you do it random. You don't need to pick, there are enough random algorithms. Python can do it for you. You just, once the model is there, if model comes up with this equation, you just, now don't give it the price. For the remaining 20 houses, don't give it the price. Give it the square feet area and the bedrooms, and it will tell you the estimated price, and you see how much it is varying from the real price. So sum of residual errors is what you do in statistics. Don't bother knowing it, you can easily take statistics course, it's not a big deal. Sum of residual errors is what you are trying to minimize. So if your estimation error is too much, say like 10%, 15%, what you do is you retrain your model. You get more data, you get more features, you talk to real estate agents, what am I going wrong here? You improve on it and then you fix the problem. But you always have that 80-20 split for training and test data. Is avoid overfitting the data, the model to your training data. What do I mean by that is when you create a model, it works very well for your training data. That means you randomly pick any data point in your training data, it estimates very well within certain percentages of error. You give it some other thing, another data point, it fails absolutely outside of training. That happens when you try to overfit. For example, let's see these estimations. This is underfit. So it's missing that point. And this is overfit. Suppose I have another house somewhere here, it will tell me that this is the estimate, which can be totally way off. Because this model is trying to be good itself, it's proving itself that I'm so good, that I'm good for this training data, which is wrong, come on, because you can't have the entire house sale information of entire Hyderabad. You can't have it, you have to take a sample and you have to create your model. So don't overfit it. When you are going to this kind of, this is a fourth degree polynomial equation. If you go to that level of complexity, you will overfit, it works in your lab, it fails in real life. You underfit, again the errors. These are the two big causes of error. That means if you have too small of a sample size, or you have variables, too few variables, either underfit or overfit happens, and your estimation is way off. So there is somewhere a sweet spot where it's just about right. You are still off, but not too off. That's the thing with machine learning. Machine learning never tells you that this is it. Even if you show it a dog, it tells you that I'm 90% confident that dog, it could be 10% cat. Okay. So what I was talking about is the prediction models is called supervised learning. The supervised learning, what we are doing is we are actually in the training data, we are labeling the data, we are actually giving it the price. So another very famous example of supervised learning is classification. In addition to prediction, what we do in supervised learning, artificial intelligence example, machine learning example is classification, which is very famously used in natural language speech recognition and also in image processing, etc. Where when you hear an audio, you are trying to classify which phoneme it is. So I'm just quickly giving how natural language speech recognition models are built. What you do is when you articulate something, it actually depends on your human physiology. That's why voices vary from one person to another. So that's why voice biometrics. You have seen the James Bond movie? I'm born James Bond and it opens the door. It actually happens in Nuance headquarters. I used to say I'm Vijaya Kurada and the door used to open. It's used in voice biometrics as well because when you articulate something, the audio signal is very sensitive to your physiology. So we extract the right features, we create a model for you. And then we compare it against a generic model and then we'll check whether you are who you are as you claim to be. And then we'll allow. So voice biometrics work like that. So another thing that is natural language speech recognition is when you talk to the system, the way I've talked to Siri, you need some way to tell the model, basically what we do is we build the models of English language, for example. Telugu also is there in India. We have released Telugu model also. It works reasonably well and we have used a lot of Telugu songs data to train it. Because that was easy for us to collect the training. We have collected data, we have collected data, but a lot of songs data, but we had a lot of trouble. That's a totally different story. So coming to the language models, the way it happens is acoustic models. Whenever you say something, the audio signal, digitally it looks like this. If you have done your digital signal processing course, you know. When you digitize it, your amplitude and your frequency, everything varies. So you take small samples and then you try to recognize. What exactly are you trying to recognize? You are not trying to recognize words. You are trying to recognize phonemes. Hence, you may have heard of phonetic spelling, like cat, bat, rat, mat, dat, whatnot. So they all end with yat, but just the first syllable changes. Similarly, cat, category. Category, you already have co-yot model, you just need to build the models for ergory. So in American English, it's just 48 phonemes. Entire American English can be modeled by modeling 48 phonemes. The audio signal match, you can just do with 48 phonemes. Indian English is also not very different, it's some 50 plus phonemes. Hindi, I think we could do with some 60 plus phonemes. Hindi is also not that complex. Hindi is a little bit more complex, but it's not that complex. So you create models for that, and then you sample the signal at you sample the audio signal at like 10 millisecond frame length. Human physiology fortunately is such that you can't speak at such a fast rate that nothing changes. In 10 milliseconds, you can't switch to another phoneme. So that's very good sampling rate, which is very easy. It doesn't even take much storage space or processor power, but it does take a lot of processor power for some other reason. Either way, we sample, we try to see whether it is whatever. If that were easy, I would not be here. So there's something else going on. The problem with that is just using phonetic models is that there's a lot of confusability, right? Especially the way we pronounce, we do not pronounce like we'll just say cat. So there's what we say co-articulation. And we also, the phoneme combinations, some of them are illogical. You can never pronounce busy. I don't know what is busy. But if you just model it, It is actually thinks that busy is a logical word. So what we do is we actually superimpose, we create another model called language model, where we throw the legal words. Legal means not the court of law legal. It's just the words that are in the vocabulary, in English vocabulary, that are most commonly used for a given context. We create that model and we use it in conjunction with the acoustic model. The first one that I described is an acoustic model. In acoustic model, we take a lot of audio, we literally transcribe it and tag it. By now, you should know what is a tag. You must have done a lot of hashtagging in Twitter. So you tag it to be what is what. This audio, the human transcribers actually listen to it. What they do is they tag the words. We collect a lot of training data, like we have say some Pawan Kalyan dialogue or something. We take like sample it and then we tag it. He said something. And then we give it to the model, so it has enough tagged utterances, and then we superimpose language model, so we are constraining so that it doesn't come up with illogical words. On the top of it, we also constrain further to improve accuracy the vocabulary for a given context. For example, for Siri, the vocabulary is not so much medical. You're not, this is just very basic medical questions you may ask. Do I have fever? But you will not ask what is sphygmomanometer. So that kind of vocabulary there's no need for Siri to know. So for medical transcription, we do have, of course, medical vocabulary we create here, we use it. So depending upon the application, we use another model. So combination of the model, and then we give the acoustic signal. We extract the features, the way we talked in the house price, the required features. We give it to the model, and the model will come up with the recognition result, which is its best guesstimate. This is an example of what is a possible word at the end. Another example of machine learning is called unsupervised. All this time I have been giving you examples of if you know the price already, if you know what the user said already, and you are transcribing and you are giving it the data, basically you are labeling that this is what it is. Suppose there are scenarios where you know that there are natural classes in the data, but you are not sure how to classify it. So in that case, you will use clustering. This is another one of the very famous examples of machine learning. Like for example, it's used in biological species, it's used in image processing, etc. I'll just give you a very simple example. It's not very realistic example, but I'll just give you. Suppose there's a lot of image data. Like, that may have like all kinds of images, like Google, the way Google faces. There's too much of image data on the internet. So you want to make the machine somehow classify them as separate, like at least the basic classification, like humans all in one group. Let it not call it humans, but at least let them group into humans as humans, monkeys as monkeys, donkeys as donkeys, cars as cars. Let it first classify it, but not name it. It will just let us dump them into separate classes. Then human transcribers can go, and that's very easy for them. If they see non-human in human data, they'll just say it's non-human, it's an error, I will take it out. So it will reduce a lot of human work. And it will also allow the machine to learn the features for each class. In that case is what cluster seeking algorithms are used. In a very simplistic way, for example, you have, say, a lot of images, right? Let's say you have a lot of images of vehicles. So the machine, and then you will give some variables like the number of wheels, the size of the vehicle, the number of people it can carry. You just tell the variables, you don't label what image is what. You just tell the cluster seeking algorithm that there is data, you use these variables, number of wheels, etc. And then in this image, whatever, you figure out, okay? So it says, alright, it has two wheels, and it has, okay, 2 wheels is separate from 3 wheels and separate from 4 wheels, it will separate. And within two wheels again you will see, okay, it can carry one person versus two persons, it will separate. So it will at least give you the basic classification. Later you can label and then use it for supervised learning. So this is another very big example. This is just, and this is also used in cancer research. Both the healthy cells and cancer cells are given to the system and then allow it to cluster it. It will cluster separately and then you can label it. Then you can see why, how it like on what basis it separated them. Then you figure out, then it is very much used in medical field also, cluster seeking algorithms. So this is the basic foundation of the models. We have already talked about the challenges in building the models. It's very, very important that you have the enough quantity of the data and enough sufficient quality of the data in terms of the features. The right features you have to give. It's not about how many features. Are you giving the right features or not? It's very important. That's where the domain knowledge comes into picture when you're creating the models. Let me just give you an example of real life situation. Something unfortunate happened with Google recently. They have TensorFlow, I think that's what it is, their image processing application is. They put it out and they asked the users to use it and let the image processing application from Google classify it. So what one journalist did was, he was testing. New York Times journalist, I think. What he did was, he gave it a few pictures of car, recognized as car. He gave it a picture of bike, it recognized as bike. Gave it a picture of aeroplanes, recognized as aeroplanes, flowers, fine. He gave it a picture of two black people. It tagged them as gorillas. And that's really a big PR disaster for Google. Now if we know how it can happen, okay, we know it's not, Google is not racial, they're not making any racial statements here. It's a pure technical thing. They did not have enough data. They did not have enough data for both classes. Neither for black people nor for gorillas, right? That's when the confusion happens. The confusibility of classification is a very big problem. And it's a huge PR disaster. Google being Google, they immediately recovered from it. They tweeted immediately saying, sorry, what they did was, even Google being Google, they could not solve it. But they did a workaround. They removed the label of gorillas from their classification algorithm. So even if you give real gorilla, it won't tell you it's gorilla now. Okay, that's okay. They recovered from the PR disaster, but they had to figure out, fix their problem of modeling because it takes a lot of time. That's how challenging modeling is, because you know now, you have to have enormous amount of gorilla data, you have to have enormous amount of black data, and label it, ensure that your estimation error is close to zero, especially in the US where there is racial issues are there. So Google, I think for a while we don't see gorilla labeling anytime soon. Another thing about semantic modeling, another example. Let me ask you a very quick English question, grammar. This trophy doesn't fit in this suitcase. It's too big. Listen to this carefully. This trophy doesn't fit in this suitcase. It's too big. What is too big? Trophy is too big. But as per the English, when you have two nouns, when you say it in the next sentence, it refers to the second noun. Ram and Lakshman are fighting. Lakshman fainted. Who fainted? Lakshman, right? As per English, it's the second noun. The it refers to the second noun. But in this case, all of you said trophy. Why didn't you say suitcase? Because it's common sense. If trophy, suitcase is too big, why wouldn't it fit the trophy? It's common sense. But machine doesn't have the common sense. It will go with grammar. The semantic interpretation model is failure. It's very difficult. So even with lot of research we have done, we still face, this is one of the last big problems we face. Even in the, I've done lots of, my focus was on human-machine interface. I've struggled a lot with semantic meaning interpretation, especially in India. Come on guys, Indians are multilingual. I got heart attack when I first deployed the models in India. They don't talk one language. I don't know what they talk, but it's not one language. And they don't finish their sentence. There's a lot of side talk. There is too much of noise, everything was thrown into it. And another thing that Indians do is the famous head shake. The system asks, you want a dabang, right? What does it mean? This is yes, this is no. But what does this mean? And first of all, we don't have the body movement recognition at all. That's another research going on at IBM. Nuance is not doing, but IBM is doing. First of all, head shake doesn't work with natural language speech recognition system. Even if it works, Indian head shake doesn't work. And then they won't say hi or na. Hi or na is very difficult to recognize. In natural language speech recognition, you better have some signal. If you have too short signal, it is susceptible to noise in there. And Indians, we were trying to recognize. Tell me your account number, please. 16-digit ICICI account number. 1, 2, 3. A value better 4, 5, 6. Ah, come on. I cannot recognize what you just said in between. We had faced so many problems that we had to go with, a combination of speech and determined backup, the touchtone backup, which we are also doing in the US, but US is more homogeneous. At least once they say that they are going to speak in Spanish, they stick to it. Once Indians tell us that they are going to speak in English, they hardly stick to it. It can be English, it can be English, but it is never English. So we have to come up with lots of front-end innovation to make very basic things work in India. So it's very challenging. India is a very beautiful country. If you can make things work here, you can make things work anywhere else. Okay. Another thing with machine learning is, as I just told you, the Indian English models, we need a lot, for us to optimize and improve, we need a lot of real-life deployments. Right? Or we go to ICICI, we show them the demo, they are like, alright, it works, but we don't know if it works in the real life. Fair enough, right? So we go for pilot and it doesn't work. For all the reasons that I told you. That's a catch-22 situation. For you to improve your model, you need a lot of data from real life. Customer will not let you go to real life unless you improve your model. It's a tough situation. So this is one thing you need to keep in mind when you are working deployments somehow. That's what Siri did. Remember when Siri was initially deployed, accuracy was very poor, but it was like a toy. So people actually gave it a lot of data unknowingly. Okay, so now that takes us to the most important part of this presentation. If you are interested in careers, or if you are interested in starting your own company in machine learning, what are the phases? So you have a few options, but whatever you do, start with an application. Have an application in mind. What are you going to do? Like, okay, I'm going to do something what Zillow did in the US. Or I'm going to do what Airbnb is doing. I'm going to do what Amazon product recommendations are. Or I will come up with something new, like, the predicting what percentage of electrical engineers are likely to go into electrical engineering after they graduate. Some model. That might help your placement cell. So something. Have your application ready in your mind. Then think about what to do with the model. You have two options. You can start from scratch. You collect data, build models, you do the platform integration. Are you going to do it on Android, iPhone, laptops, IVRs, whatnot? That work also you have to do. Or you have another option. Readily available models are there. From Nuance, from Google, from whatnot. You can choose. You can take readily available models, build a front-end interface on them, and then deploy it in real life as an application, as your own application, or you start from basics. So you decide, if you are a startup, decide where you are going to play. Are you going to play this whole game? You are up and against some big companies, but sometimes if you have a niche, you can actually do it. Or you take the licensed models, like for example, Sidepal has licensed models from Nuance. What it does is it creates avatars for you. So, for chatbots, you can insert a chatbot into your website, And you can choose the avatar and you can give it which language it should speak to the customer. They are called text-to-speech models. And those models, they are literally licensed from Nuance. They just give the text and Nuance will pay for them, and that's fine. So they're very quick and up. Sideball is very quick and up running. And then you have to, of course, pilot and optimize. This is very important for us guys. You cannot just skip it. Whatever you are doing, your innovations, you pilot it to a real-life sample, real-life people. Find your guinea pigs, pilot on them. Give them free incentives, pilot on them, and then optimize your models. Then you do the launch, and this whole thing repeats. This whole cycle repeats. You collect data, improve models, launch, find new applications, etc. So as I said, for entrepreneurs, you're either you're doing the entire product life cycle. Basically, the upside is you have more control because it's your data, you can collect, you can improve, it's your algorithm, etc. The downside it is heavy investment. Data collection is not easy, and data preparation is not easy. You need machine learning specialists. You need to hire them from IT because OU is it, I guess. But I think computer science is coming up, I guess, right? Hopefully. But it doesn't matter, I'm pretty sure, because our guys are very smart, you can easily pick up. But either way, resources heaviness is there, either from data or from the human resource perspective. But getting better, this process, because tools like Turi, formerly known as Dato, and MATLAB, etc., or even Google, they are providing the machine learning algorithm tools. So you can just have the basic knowledge of algorithms and you can still build the models. And our license technology, which we have talked about, are by our license models, bootstrap models. There are a lot of open source projects going on, like Alexa and all that. Even Google has open source, the TensorFlow. Amazon has open source models. You can start from there, you can improve on it. That's an option for entrepreneurs. And careers, and suppose you are not so much interested in starting your own company or interested in careers, what kind of careers are available? If you go back to the product development life cycle, you will see that there's a one-on-one mapping to the careers. You see that for each phase you need resources. So the first thing is data scientists. As we discussed, a lot of data pre-processing has to happen, data collection, data labeling, etc. So you need data scientists, and they usually come with a lot of industry knowledge as well as the statistics background. And machine learning specialists who are good with all these algorithms, like Viterbo beam search, k-means, nearest neighbors, all those algorithms, HMMs, deep neural networks, etc. In some companies, these two are one and the same. In some companies, they are two different roles. And then you have platform integration specialists who can take these models and integrate with any platform that you are looking at, Android, iPhone, iOS, etc. And then you have application designers. This is a very beautiful skill set to have, because this is where the crux of it, you are building the application to the consumers, the user interface and the user experience designers. This specialization you can do. And then you have application developers, the front-end application developers. Then you have business analysts who can go into a customer site, understand their problem, propose an appropriate solution. That's another skill. For that you don't need to have anything deep, but just enough. So you're jack of all trades, master of none. Go for business analyst positions. Project managers are usually, you don't become a project manager on day one. You join the industry, you show a lot of interest in management if you can survive the whole project phase and resource allocation, the human resource management, etc. Project management is a good step for you. Start looking into that area from the first year of your career. Management is different from any other career, so you need to build yourself. Spend a lot of time with project managers, understand, take project management courses, but project management and general management is mostly hands-on, learned experience. So is product managers. The difference between project manager and product manager is product management is marketing. That means you're bringing out a new product, then product managers own the product and they bring it out live. So you need to have, in addition to project management skills, you need to have the marketing skills to become product manager. And general management. General management, you grow within the industry over the time. So in closing, as we discussed, the gorilla example, the trophy example, it's not easy. It's not for faint-hearted. It's multidisciplinary. It's hardly one field. It's a combination of many fields. It's statistical and data intensive, yes, but not all roles in the machine learning or artificial intelligence industry need to know statistics. If you're front end, you're not spending that much time. Works in the first try, usually not. We know why. Usually doesn't work that well in the first try. You need to do multiple pilots. Getting better, yes. Front end design matters absolutely. You have to really focus on the front end design, whoever is doing it. Resource availability an issue to deal with. Worldwide it's an issue to deal with. It's not just India's problem. Worldwide we have an issue with not only data resource and also the engineers are in short supply in this field. Requires big investment? It depends. It depends what you are trying to do. If you are trying to do the entire product life cycle, it does require big investment. If you are going to start with bootstrap models or if you are going to license others, okay, you have a starting point. Rewarding when it works, absolutely. So let me close with one of my, the real life experience I had. I think it was in 98-99 time frame when we deployed Delta Airlines application. It was a flight schedule application on IVR. In contact center, it was actually replacing a human. So we deployed natural language speech recognition system. I have designed the front end for that and I have designed the vocabulary for that. So when it went for pilot deployment, I went to Delta Airlines and we were doing live monitoring of the calls. We were intercepting the calls on a speaker, their marketing specialists and us, we were live listening to the calls as they were coming in. Kind of an old lady, she came in. She called, she talked to the system. The system said, welcome to Delta Airlines flight scheduling system. It actually said system. I've intentionally designed it to say system, to set the expectation. And then it asks questions like, where do you want to go today? From Boston to York. There's no York in the US. But the way I've designed the system is whenever we recognize it as something, we are going to play the city and the state back. Like Hyderabad, Telangana, Visakhapatnam, Andhra Pradesh. Even if the caller just says Hyderabad, we were going to play back Hyderabad, Telangana. So similarly, when she said North, the system came back and said Newark, New Jersey. She pronounced it like that. And the caller said yes. Or like, oh, thank God. We didn't recognize, but the system recognized. So it went on. She finished the scheduling, but the actual pricing we were transferring to the agent because that was a pilot deployment. So at the end, it said, okay, thank you for all the information. I'm going to transfer you to an agent. Then she said, thank you, madam. I didn't guess it. I didn't guess that somebody is going to say thank you, madam, to the system. So I treated it as a recognition error. And the system came back and said, sorry, I didn't understand. She was blown away. She understood North. She understood Boston. She understood everything. She didn't understand thank you. What kind of a human is she, right? And she said, I said, thank you. I said, I'm sorry, I still didn't understand. Like, no, madam, I said, thank you. And now it really, the tone has changed. It triggered another recognition error. The tone gets worse, recognition error gets worse. But fortunately, I had to set the limit as 3. 3 consecutive errors, go to the human agent. I said, okay, I'm going to the agent. The agent picks up and she says, you know, something interesting happened. I talked to this sweet lady, she helped me with everything, but she didn't understand thank you. I started laughing and said, you just talked to your computer. She said, oh my God, I've talked to the computer. I'm like, yes. You know why? The computer passed the Alan Turing test.
you, ma'am. In the interest of time, again, just wanted to remind that all the faculty members, please assemble up in the head sir's room, EC department. We'll have a separate session with Kanan sir and Vijaya ma'am to personally interact. So let's have some questions from the students, probably just 2 or 3 in the interest of time. We'll ensure that in the next couple of weeks, we'll again have a hangout call. Whoever has questions, you can get on a call with both the alumni. Okay, so from the students, any questions, please?
That's my opinion, as it is. Yes, and there are a lot of queries around it. For example, already computers have started writing news articles. You can't really tell apart whether computer wrote it or a human wrote it, and now you know how they do it with machine learning modeling. If you do enough modeling of the news articles, computer will write. They started writing stories. Google has access to millions of books. Google is working on story writing robot, which is a software robot. Is it a threat to human employment? Yes. Is human employment the only way to live? No. That's a problem of macroeconomics. But as machine learning and artificial intelligence engineers, we are very bad. We are going to continue with this. Yes, we do. Especially in the US English, right? They go against grammar, all the known grammar. You know that 2 positives can never make negative, but in US English it does. Yeah, right, it's negative. Yes, we had to forcefully model in conversational natural language speech recognition system using that vocabulary model that I was talking. So we would tag it as no, or we would tag it, we would recognize it depending on the context. If it is yes, right, that is yes. Yeah, right. But we can't recognize tone. Tone is not in the model. The research is going on. But it depends on the context, sarcasm. The way we handle it depends. Sometimes we intentionally recognize and reject it, like sorry, I didn't understand, although it understands. To avoid setting the expectations to the user that it can understand sarcasm. Might understand this, may not understand that. So we try to keep it to the it depends on the application. If your application is like a comedy kind of an application, you can model a sarcasm. And there was such requests in India from Airtel Value Added Services. They asked us.
Last question.
Yeah, it depends on the company you're working for. Data in some companies they are treated as one only, like data scientists and machine learning. In some companies, what they do is they don't want their machine learning specialists who are usually the PhDs in computer science, specializing in so many algorithms, to bog themselves down with a lot of pre-processing of the data. A lot of pre-processing has to happen, like noise has to be taken out, the smoothing the data, labeling and all that, they give it to data scientists. But in some companies, they're one and the same.
But they have amazing courses on data science, machine learning, and AI. So definitely do check it out. And IIIT, again, they do tremendous amount of research on. They are one of the best in Asia on NLP and all these different areas. So that's another really good place to check out. So in the interest of time, if one last question, if any of you have, or we'll just move on. Okay, so people out there. So to just conclude the session further, I would like to invite Mr. Vijay sir.
Pretty interesting and a lot of insights into technology as such. I would like to thank on behalf of the association and the students and everyone for to Mr. Kanan as well as Mrs. Vijaya for delivering a fabulous lecture. But at this point of time, I also thought it would be right to make an announcement which actually was scheduled on the 31st. Okay, because I thought it was the right podium to do the announcement. We talked about benefits, we talked about knowledge trickling, we talked about collaboration, we talked about so many things when I spoke to you guys initially. But most critical and important also is how the alums are helping the institution and the students directly in terms of contributing to their enhancement of technical skills or getting into research and funding. So at this point of time, I'd like to announce, I'm sorry, Vijaya, it's a little surprise, okay. Vijaya is funding a research project which is basically in the innovation space. And the project was finalized and forwarded to her and with recommendations. One of our students of electrical engineering, Nikhil, is the guy. Innovation in the electrical meter space. So I think he might come back to you and you for it. Okay. So I think it's a very, very benevolent thing, and not only Aruna but her batch also is looking at doing a lot of stuff over here, and every batch that comes. So please do respect the alums when they come. There's a lot that they want to give to you guys. Take it with open arms. Okay. So we do understand it's slightly painstaking for us to sit or class or cancel a particular class and sit through these sessions. Maybe we're all typical students like you. We also were sitting on the other side and we always felt bored, but look at it from a different angle. I think there has to be a paradigm shift in the way we look at these whole sessions. Here are people who are coming with open arms to give you something. Please accept them with grace and open arms. There's specifically students, there's a fantastic platform for you guys to move forward. Okay? And I thank the batch of 1991 Electrical, as well as specifically Vijaya, who spearheaded the whole thing and took this or make it happen. Okay? Thank you, Nikhil.
Interact with a smart student like you.
From the students, and even if any of you have any other innovations that you need support, be it technically, be it monetarily, or any other way, definitely reach out to us. We have an innovation committee spearheaded by really eminent guys in the industry. So just reach out to us and we'll figure out how we can help you out. And definitely, just like Vijaya ma'am, there are like many other batches who are coming forward to help you out. So definitely use this opportunity. So I would request all the dignitaries to come back to the dais. Presidents. So I'd like to request President Sir to get the book.
While we were sitting and engrossed in the lecture of Vijaya, quietly walked in our chief patron and the principal of the college. In fact, he has to come and join us, and we welcome Mrs. Fatima, the principal and chief patron of Alumni Association of Engineering College.
Thank you very much.
I'm sure everyone is excited.
As long as it is short, you have the patience to listen.
Yeah, the timer starts.
When you say teachers should be short, teachers don't know the meaning of short. My NLP does not recognize short. Speaker of the day, Vijaya, Kurada. I have not attended the talk, but I think Mr. Kannan Tinium is also here, who addressed the gathering before Vijaya. And then our president, Mr. Ram Mohan, who's an inspiration, who's been sitting all through the talk. So hats off to Vijaya. You made him sit for 1 hour. Our good friend Vijay Kumar, the smiling face of this College of Engineering, and my dear students. This is the first time, I guess, I'm addressing the students after taking up as the principal College of Engineering. I'll try to be very short, sir. I think Madam has done such a lovely job, she introduced the subject by asking a few questions and then showing you some slides, giving you an overall picture. And then after, she went into the different techniques, the classification and the clustering topics that she's covered. And then she went on to the applications. And of course, the practical applications were mentioned by her in her talk, I think, which was wonderful. So in this short span, I couldn't have done so much justice to the subject. But however, I would like to summarize what she said. What she's been saying is basically two things I understand. Correct me if I'm wrong. One is she's trying to extract data, the right kind of data, and then she's trying to build a model around the data. These are two important things that we should take home, I think. I'll tell you one kind of research that went on. One set of students took a froggy, papa, right, to jump. Froggy jump. The frog used to jump. Okay? Whenever they said froggy jump, the froggy was jumping some distance x. Okay? Then they chopped off one leg. They said froggy jump. The frog jumped distance x by 2. Then they cut off both the legs. This time the froggy did not jump. So they concluded, if you cut one leg of the frog, then the hearing power comes down by half. It becomes deaf. Extract the data properly, identify the dependent and the independent variables, okay? And then build an appropriate model to get the right results. Okay? There's so many models sitting there. Okay? And Vijaya has been alluding to neural networks or maybe clustering k-means or whatever. Okay? So I think you have so many models around there. Which one suits you best? That is the important thing. Right? So I think the whole course is circled around this idea of what are the models and which one to pick up when you need to. Second thing, she was talking about speech prominently. So she's been applying machine learning to speech, right? But today we are in the era of multimedia. So you have not just speech, you have audio, you have text, you have your database tables, right? Okay. So now you can do this machine learning for anything. So what she said was for speech, but you can still extend the idea for other multimedia data. Now, I being a teacher, the last thing I would do is I would put a quiz. Without that, my lecture will not. How many of you Google 5 times a day? Everything must be doing. How many times you do instant messaging? So what is the data that you're generating when you're doing all this? When you're messaging? It is textual data. It's not the database data. It's not structured. It's unstructured. Okay? So handling structured data versus unstructured data versus speech data. So she even described the different models, you know. She said you have to first have the language model, and in that she had 2 components and all that. So there she described, you know, how to pick up the frequencies and then identify the phonemes and so on and so forth, one part of it. And the other part she said the language model. So those were the 2 things that she spoke about speech. Now these models may change depending on the media you're operating with. If it's text, the techniques are something. I mean, more or less broadly they're the same, but the steps involved may be slightly different. Okay? There are phonemes there in speech. Okay? So for text, what would you have? You have to go back and revise your grammar. Syllables. Right? For text, we have syllables. So this way things change slightly. Okay? That's all that there is to it. So I think this is what I wanted to summarize as to what she said. I think I've done a right summary of what you've done. Okay. So I think with these few words, I should thank the speaker and the alumni who have been so good at this. At this hour, putting together such a big crowd, I couldn't have done. Okay. So hats off to them, and thank you very much. The speakers.
At the end of the day, it's very easy to skip something, but to come down to do to spend that kind of time to educate you guys and help you understand the basic concepts of a lot of these things, it's a wonderful thing. So one big round of applause for our speakers. Making it a grand success. I'd like to thank the President Sir, the General Secretary and rest of the board members for helping us put this together, and the student volunteers. And yeah, we'll have the bouquets for the Rammohan Sir. But yeah, so now.
Frankly, I don't blame Pradeep because still he has got the elbow.
Just trying. Thank you. So, as a last thing, definitely remembering. Thank you again. So, for sitting through for the last 3 hours, we have some snacks for you. So please.